Dear student, Assalamu alaikum. In econometrics, today we going to learn what is multiple linear regression model. Outcomes. After watching this video, you will be able to understand multiple regression model, assumptions, R square, examples of the multiple linear regression model. So first of all, we define what is the multiple linear regression model. Multiple linear regression model, also known simply as multiple regression, is a statistical technique that uses the several explanatory variables to predict the outcomes of the response variable. Multiple regression is an extension of the linear OLS regression that uses just one explanatory variable. In essence, multiple regression is the extension of the ordinary least square regression that involves more than one explanatory variables. The formula for the multiple linear regression is yi is equal to beta naught plus beta 1 xi1 plus beta 2 xi2 plus so on and plus beta p xip plus epsilon, where for I is equal to 1 number of observations, yi the dependent variable, xi the independent variables or explanatory variables, beta naught y-intercept or constant, where the beta p the slope coefficient for each explanatory variable, and in the last epsilon is the model error term, also known as the residuals. Explaining the multiple linear regression. A simple linear regression is a function that allows an analyst or statistician to make predictions about one variable based on the information that is known about the another variable. Linear regression can only be used when one has two continuous variables, an independent variable and the dependent variable. The independent variable is the parameter that is used to calculate the dependent variable for outcomes. A multiple regression model extends to several explanatory variables. Assumptions of multiple linear regression model. The multiple regression model is based on the following assumptions. There is a linear relationship between the dependent variables and independent variables. The independent variables are not too highly correlated with each other. Yi observations are selected independently and randomly from the population. Residual should be normally distributed with the zero mean and constant variance. Now let's talk about the coefficient of determination, that is the R squared. The coefficient of determination R square is the statistical metric that is used to measure how much of the variation in the outcome can be explained by the variation in the independent variables. R square always increases as more predictors are added to the multiple regression model, even though the predictors may not be related to the outcome variables. R square by itself can't thus be used to identify which predictors should be included in the model or which should be excluded. R square can only be between 0 and 1, where 0 indicates that outcome cannot be predicted by any of the independent variables and 1 indicates that the outcome can be predicted without error from the independent variables. So how to interpret the multiple regression model's coefficient? When interpreting the results of the multiple regression, beta coefficients are valid while holding all other variables constant. The output from the multiple regression can be displayed horizontally as equation or vertically in the table form. So let's take example how to use the multiple linear regression. For example, an analyst may want to know how to movement of the market affects the price of ExxonMobil, in short form XOM. In this case, his linear equation will have a value of the S&P 500 index as independent variable or predictors and the price of the XOM as the dependent variable. In reality, there are the multiple factors that predict the outcome of an event. The price movement of the XOM mobile, for example, depend on more than just the performance of the overall market. Other predictors such as the price of oil, interest rates, price movement of the oil futures can affect the price of the XOM and the stock price of the other oil companies. To understand the relationship in which more than two variables are present, a multiple linear regression is used. Multiple linear regression is used to determine the mathematical relationship among the variable of random variables. In other terms, MLR examines how multiple independent variables are related to the dependent variable. Once each of the independent factor has been determined to predict the dependent variable, the information on the multiple variables can be used to create the accurate prediction on the level of effect they have on the outcome variables. The model creates the relationship in the form of the straight line that best approximate all the individual data points. Example, referring to the multiple linear regression equation above in our examples, yi the dependent variable, price of XOM, xi1 interest rate, xi2 oil price, xi3 value of the S&P 500 index, xi4 price of oil futures, where beta node, beta 1, beta 3, beta 4 and so on all the coefficients and slope values. The least square estimates beta 1, beta 2, beta 3 and so on are usually computed by the statistical software like SPSS, eViews and Stata. As many variables can be included in the regression model in which each independent variable is differentiated with a number 1, 2, 3, 4 and so on and p or k. The multiple regression model allows an analyst to predict an outcome based on information provided on the multiple explanatory variables. Still, the model is not always perfectly accurate as each data point can differ slightly from the outcome of the predicted by the model. The residual value epsilon, which is difference between the actual outcomes and the predicted outcomes, is included in the model to account for such slight variations. Assuming we run our XOM price regression model through a statistics computation software that returns this output. XOM price is equal to 75. 75 is the beta node minus 1.5 interest rate plus 7.8 oil price plus 3.2 S&P 500 plus 5.7 oil futures, and the R square is the 86.5%. An analyst would interpret this output to mean of other variables are held constant. The price of XOM will increase by 7.8% if the price of oil in the market increase by 1%. The model also shows the price of the XOM will decrease by 1.5% following a 1% rise in the interest rate. R square indicates that 86.5% of the variation in the stock price of the ExxonMobil can be explained by the change in the interest rate, oil price, oil futures and S&P 500 index. Key points: multiple linear regression, also known as the simply multiple regression is the statistical technique that uses the several explanatory variables to predict outcome of the response variable. Multiple regression is an extension of the linear regression but uses just one explanatory variable. MLR is used extensively in econometrics and financial inference. So difference between the linear and multiple regression. Simple linear regression model is the relationship between one dependent and one independent variable, whereas the multiple linear regression model is the relationship between one dependent and set of independent variables. Thank you.